Here is today's objective. I can identify factors of a number. We're going to work our way through some story problems, and at the end of the story problems, you'll see how the examples relate to factors. Here's our first story problem. A candy shop wants to pack 12 candies into boxes. Each box holds 3 candies. Can the candy shop pack the boxes so there are no leftover candies? To solve this, I want to draw a picture. Here's my box. I'm going to put 3 candies into the box. I'm going to keep packing my candies until I've used all 12 of them. Another 3 will give me 6. If I pack another box of 3, I would have used 9 candies. And finally, pack one more box of 3, and I will have used all 12 candies. The question was, can the candy shop pack the boxes so there are no leftover candies? The answer is yes. We don't have any leftovers. All of the candies fit nicely into the boxes. A candy shop wants to pack 12 candies into boxes, just like before. Each box holds 6 candies. Can the candy shop pack the boxes so there are no leftover candies? This time they want to put 6 to a box. So I'm going to draw my boxes. Here's the first one. I'm going to pack 6 candies into it. And keep going, pack another box of 6. Oh, and look at that. I've used all 12 of my candies. Can the candy shop pack them so there are no leftovers? Yes, all the candies, again, fit into the boxes nicely. A candy shop wants to pack 12 candies into boxes. Each box holds 12 candies this time. Can the candy shop pack the boxes so there are no leftover candies? Here's my box. They want to put 12 in a box, and they've used up all 12 candies. So again, our answer is yes, the candy shop can do this without any leftovers. Let's look at this one. A candy shop wants to pack 12 candies into boxes. Each box holds 5 candies. Can the candy shop pack the boxes so there are no leftover candies? All right, here's my box. They have 5 in a box. I'm going to keep going. Pack another box. Now I've used 10 candies. Can I pack another box of 5? I can't, because I only have 2 candies left. So this time, the answer is no. The candy shop can't put them in boxes of 5 without getting any leftovers. In each of the examples that we did, the numbers that you are multiplying to get the product of 12, those numbers were called factors. In this example, we had 3 and 4. There were 3 candies and there were 4 boxes. When we multiplied, we got 12. Then we had 6 candies in 2 boxes, and we multiplied that to get 12. And finally, we had 1 box that had 12 candies, and we multiplied that to get 12. These numbers, 3, 4, 6, 2, 1, and 12, are all factors of 12. Okay, they're factors of 12. They can be multiplied by another number to get 12. If we write them as a list, I can write them from smallest to largest and list them out. 1, 3, 4, 6, and 12 would all be factors. Now, remember that example where I asked you about the 5 candies? Can 5 candies be multiplied by anything to get up to 12? If we do 5 times 1, we would get 5. If I did 5 times 2, I would get 10. If I did 5 times 3, I'd get 15. There's no way to multiply 5 by another number to end up with 12. So 5 was not a factor of 12. What are the factors of 20? We want to think, what can I multiply to get up to 20? Can I do 1 times anything to get 20? Well, 1 times 20 is 20. So 1 and 20 would be factors. What about 2? Can I do 2 times anything to get up to 20? 2 tens make 20. So 10 and 2 would be factors of 20. What about 3? Can I do 3 times anything to make 20? If I count by threes, let's see. 3, 6, 9, 12, 15, 18, 21. That goes over. So 3 is not a factor of 20. What about 4? Can I do 4 times anything to get up to 20? I can do 4 times 5. So 4 and 5 are factors of 20. What about 6? Can I count by sixes to get up to 20? 6, 12, 18, 24. That goes over. So 6 would not be a factor. Well, I'll just speed this up for you so you don't have to go through all the numbers. 7, 8, and 9 are also not factors of 20. So I'm just going to stop here and write this as a list. If I wanted to write all the factors of 20, I'm going to start with my smallest number. I would say 1 is a factor of 20. 2 was a factor of 20. 4 was a factor of 20. 5 was a factor of 20. And then I had 10 is a factor of 20. And 20 is a factor of 20. 120 makes 20. So those would be all my factors of 20. Let's look at these ones. Is 9 a factor of 18? Can you multiply 9 times anything to get up to 18? You could do 9 times 2 to get 18. So the answer is yes. 9 is a factor of 18. What about 8? Is 8 a factor of 12? Can you multiply 8 times anything to get up to 12? 8 times 1 would be 8. 8 times 2 would be 16. So no, you can't multiply 8 times anything to get 12. So 8 is not a factor of 12. We're going to play a little game in class called Factor Bingo, and this is going to be a great way for you to practice learning factors of numbers. You have a grid, and you're going to fill in the grid with some numbers, with some products actually. All the numbers in the middle are answers to multiplication problems. Okay, so all of these would be the products. Then you're going to have a deck of cards. You are going to draw a number, in this case 9. What I want to do is look at all these products and decide, do any of them have 9 as a factor? If they do, I get to pick one and cover it up. I can only cover up one number. Let me show you an example. I want to look. Is 9 a factor of 2? Nope. Is 9 a factor of 81? Can I take 9 times anything to get up to 81? Ooh, yes I can. That's a square number. I could do 9 times 9 to make 81. So I could put my counter here and cover up 81. Can I do 9 times anything to get 9? Yeah, I could do 9 times 1. So I could put my counter on 9 also. I have 2 choices. I can only pick one. I think I'm going to leave it on 81. My partner in this game can also use the number 9 and cover up a number on their game board. So you're both playing at the same time. This isn't a turn-taking game. You can certainly take turns to flip over the cards, but you can both cover up your numbers at the same time on your game board. The goal is just like regular bingo. You want to get 5 in a row, but there's a special little way to win this game. If you get 12 counters anywhere on your game board, you also can get a bingo. So you can win by getting 5 in a row or 12 anywhere on your game board, even if they're not in a row. That's all for today.